So when looking at the R2 measure over here, you can see that the calculation for this when done manually works out as per my previous explanation. So what you're doing is basically taking the actual values and then the model predicts, and then you compare the actual versus the predicted, but you also do it on what if it was a pure guess. So based on the average guess, that is the average price of a house, how does that compare against the model prediction? So what we end up with is a situation like this where you have the model is predicting an error rate of 394 divided by the 25,000 here. So this 25,000 is based on average guesses total error. So you can see the ratio is pretty small, but you need to understand these numbers over here, 394 and 25,000. These numbers themselves aren't the average dollar error. So these are not dollar amounts. They are used to calculate the R2 figure over here, which tells you how good your model is compared to guessing the average. So this is guessing the average and this is based on the model. So when you take that ratio, that's what gives you this figure over here. So these are not dollar amounts. So you can't say the prediction error of the model is always, for example, if it estimates that house price is 300,000, you can't say it's off by $394,000, for example, because that's not what this actually means. So 394 over here is the total squared error for your model's prediction, because remember over here, what you're doing is you're squaring the numbers. So this is the guessing squaring. So here, when we get to this 25,000 figure, what essentially is happening is you say, okay, the actual value is 200 and this is the guess value. Get the difference of 100 and then you square it. So you can't treat it as dollar value. And same with the model prediction. So if the actual value is 200 and the model predicts 207, so that's 7 multiplied squared. That's 7 squared, which gives you 49. So these are not dollar amounts. So it's important to understand this when using linear regression. So you can see all these, what you do is use basically, so this is the error rate, and the reason we square them is to make the error appear larger. So it has a larger effect on it, just as you do with the guess one. You do the same with the model prediction, and what you end up with is you sum the total amounts up. So 49 over here plus 64 plus 49, and then you end up with this figure over here. And so this, in essence, what the R2 is, it tells you how good your model is compared to guessing the average. So that's why we do this R2 calculation over here. So just make sure you don't understand it as dollar amounts. It's just a ratio. So don't treat it as dollar amounts, please. And the R2 figure itself, the closer it is to 1, the more accurate your model is. The closer it is to 0. So this one is pretty close to 1, because when you round this up, as you know, this would be 1.0. So the closer it is to 1, the better it is.